Welcome to the Sleepy Cosmos channel, a place where science and serenity meet. Here we explore the quiet wonders of the universe, from dark matter to string theory, all told in a calm, soothing rhythm designed to help you relax, drift, and dream among the stars. Each video is a guided journey through the cosmos, slow, meditative, and filled with real science wrapped in gentle storytelling. So if you love space, curiosity, and the peaceful side of knowledge, you're in the right place. Make sure to subscribe for more new sleep narrations every week. And if you'd like to reach out for collaborations or business inquiries, you can contact us at the sleepycosmoschannel@gmail.com. Now, settle in, take a deep breath, and let's drift into the universe together. Tonight, you are invited to drift into a quiet space, a space where the mind loosens its grip on the day and gently opens to the most delicate mysteries of the universe, mysteries that reveal themselves only when everything becomes still. When the world dims and your attention softens, you begin to sense something subtle, a truth that lies beneath the surface of the familiar, a truth whispered by the smallest scales of nature, where reality behaves in ways that feel almost impossible, yet remain anchored in real science, real experiments, real measurements carried out in quiet laboratories across the world. Tonight, you will drift toward that world, slowly, peacefully, with a mind that grows lighter with each passing breath. The night itself seems to lean in, as if the darkness understands that every deep question needs silence, and every mystery needs space. Outside, the world is settling, cars quieting, voices fading, the air growing still. But inside your mind, a small ember of curiosity glows, soft, warm, gentle, not demanding answers, just inviting you to explore at the pace of drifting clouds. You may notice your body relaxing, your shoulders unwinding, your breath becoming slow and unforced. This soft physical settling mirrors the strange stillness of the quantum world. Because at the smallest scales, particles do not move in straight, certain lines. They drift, hover, remain suspended between possibilities, until something touches them, until something interacts, until something observes, and only then does reality choose a path. This is the mystery at the heart of tonight's journey. Why does the universe behave differently when it is watched? Why do particles act as if they know whether someone or something is paying attention? Why does existence itself seem to depend on the faintest whisper of interaction? As you settle deeper into the calm of the night, you'll explore these questions with a quiet mind, unhurried, unstrained, like walking through a soft dream of physics. The smallest scales of nature are nothing like the world you move through each day. Your desk feels solid, your bed feels stable, your breath rises and falls in a rhythm that never surprises you. The classical world, the everyday world, is built on predictable patterns, cause and effect, motion and rest, objects that stay where you leave them. But under this calm surface, in a realm far smaller than atoms themselves, a different kind of reality unfolds. A reality where particles behave like waves, yet also like points, where they travel down every possible path at once, until something interrupts their wandering. A reality where the universe does not choose a definite outcome until it is touched, measured, observed. This is not a metaphor, not a poetic exaggeration, but one of the most carefully tested facts in all of physics. At the quantum scale, existence seems to wait for interaction. And tonight, you will drift through this idea as gently as a leaf floating on a quiet pond. No rush, no pressure, only deep, slow curiosity. As you listen, allow yourself to relax into a state where questions feel soothing, where mysteries feel like soft pillows for the mind. You're not here to solve anything. You're here to rest in the presence of wonder. And as your body sinks deeper into its comfortable position, your mind becomes a little more spacious, a little more ready to explore the edges of what we know. The night is the perfect companion for this kind of journey, because night invites the same softness that quantum physics demands. Quantum phenomena are incredibly delicate. The moment you shine a light, touch a particle, or place a detector near it, its behavior shifts. The simple act of observing changes the outcome. This isn't magic, and it isn't mystical, but it is deeply counterintuitive, revealing a world that reacts to being watched, as if existence itself rests on a thin line between possibility and actuality. You may feel your thoughts slowing, stretching out like long shadows at dusk, allowing more space between each idea. In that gentle space, you can sense how strange this question really is. Why does the universe behave differently when observed? What does it even mean to observe something at the smallest possible scale? Is observation something humans do only with their eyes? Or is it something any particle can do by simply interacting with another? Is reality a structure that exists independently, or is it a tapestry woven only when threads of awareness or interaction pull it together? These questions do not demand sharp focus. They invite a drifting kind of attention, a soft awareness that flows like a slow current. The mystery itself is comforting because it gently reminds us that the universe is far more subtle than it appears. While your conscious mind rests on the surface, your awareness can drift downward toward deeper layers of nature, layers where even the meaning of existence becomes flexible, where a particle may be here and also there, until something brings its possibilities into a single shape, where uncertainty is not a flaw but a fundamental property of reality. As these ideas float through you, let yourself settle even more deeply. Feel the tension leaving your forehead, the softness around your eyes, the gentle loosening in your jaw. The more your body relaxes, the easier it becomes to sense the stillness that quantum physics requires. Those tiny experiments, conducted in quiet rooms with lasers and detectors, happen in near silence. Every vibration, every stray particle of dust, every tiny fluctuation must be controlled. Because the quantum world is not chaotic, it is exquisitely precise and exquisitely sensitive. It is shaped by the faintest touch, the smallest interaction, the gentlest observation. Just as your mind tonight is shaped by the soft atmosphere of rest, darkness, and drifting thought, in the quiet of this moment, you may feel as if the world around you is slowing, almost dissolving into something more fluid. This is not disorientation. It is simply your awareness loosening its boundaries. And in that softness, you can begin to sense how delicate the link is between what exists and what is observed. You can begin to feel why the universe at its core is not a rigid machine, but a shimmering field of potential, a field waiting for interaction, for contact, for the arrival of a detector, a photon, a glance. This journey is not meant to overwhelm. It is meant to cradle you in the gentle truth that science is not only sharp calculations, it is also wonder, mystery, and the quiet joy of not fully knowing. You are preparing your mind to drift into that realm, into the strange, peaceful territory where the smallest building blocks of nature behave like whispers that speak only when spoken to. And as you drift further, you carry with you one soft understanding that observation, in physics, is not about seeing, it is about interacting. It is about touch, not visual touch, but quantum touch. The moment two systems connect, even faintly, a choice is made, a possibility becomes a reality, at least a temporary one. As the night deepens around you, feel how your breath slows, how each inhale feels like a small wave rising, and each exhale like a wave settling back into the sea. In this rhythm, you can hear an echo of quantum behavior, a constant dance between potential and presence, between drifting and settling, between what could happen and what does. You are gently entering the most subtle question science has ever asked. Why does reality seem to exist only when observed? Classical reality feels so familiar, so steady beneath your hands, so predictable in the way it responds to your actions. You place an object on a table, and it stays there, anchored, waiting, unchanged by whether you glance at it or turn away. You walk across a room, and the floor beneath you does not shift into possibility. It remains solid, stable, reliable. This world, the classical world, is built on continuity, on smoothness, on a kind of dependable calm. But deep beneath this surface, far beneath the thickness of wood and metal, far beneath molecules and atoms, there exists a realm that bears almost no resemblance to the stability you know. A realm where reality behaves like a whisper, shifting and shimmering with every slightest interaction. To enter this realm gently, imagine you are drifting downward, softly, as if sinking through layers of warm, quiet water. At each layer, the world becomes less familiar, less constrained, more fluid. As you pass below the scale of atoms, and then below the orbiting electrons, you find that the certainty of everyday experience begins to fade. The rules shift, not violently, but delicately, as if the universe becomes shy the moment you try to look closely. And at the smallest scales, you encounter the strange truth that reality is no longer a single path, but many. Not a single position, but a spread of possibilities. Not a fixed state, but a cloud of overlapping maybes. This is the quantum world, a world where the act of observation carries more weight than intuition would ever suggest. The most iconic doorway into this strange behavior is a simple experiment, so simple that it could be drawn with just two narrow slits on a sheet of paper. Yet it reveals a mystery that has troubled physicists for more than a century. The double-slit experiment, when particles, electrons, photons, even large molecules, are sent toward these slits one at a time. They behave like waves. Their patterns spread out, interfere, overlap, creating bands of light and dark that reflect every possible path they could take, as if each particle explores all routes simultaneously, dancing through space as a wave of probability. But when you place a detector to see which slit they pass through, the behavior changes. The interference vanishes, the wave-like spread collapses, and the particle chooses a single slit, a single path, a single definite outcome. The simple act of observing alters the pattern, alters the behavior, alters reality. It is not human vision that causes the change. A particle does not care whether a pair of eyes is watching. It is the presence of interaction, the arrival of even one photon or one tiny mechanism that forces the particle to commit to a definite path. Without this interaction, it lives in a superposition, a gentle blend of all possibilities. With observation, it becomes something single, something momentarily concrete. This contrast between drifting possibility and pinned-down reality is at the heart of the quantum world. And as your mind moves slowly through these ideas, notice how dreamlike they begin to feel. Possibilities overlapping, realities dissolving, paths merging and separating, like faint shadows in the fog. Classical reality feels solid and continuous. But this solidity is a kind of illusion, an illusion created when countless quantum interactions stabilize the world. But at the source, at the smallest level, nothing is solid, nothing is fixed, nothing is certain. Not until something watches, not until something interacts. This is not philosophical suggestion, but experimental truth. Whenever a quantum particle is left alone, untouched, unmeasured, it behaves like a wave. It spreads, extends, occupies a region of space, not with physical substance, but with possibility. Its reality is not a point, but a probability distribution. A shimmering cloud of where it might be, how it might move, what it might become. But when the smallest tap arrives, when a detector nudges it, or a photon touches it, or a nearby atom interacts, the cloud collapses. The many paths contract into one. The wave becomes a particle. The realm of possibility crystallizes into a single outcome. This is measurement, not a conscious act, but a physical interaction. And in that moment, quantum reality shifts from a soft haze into something brief and precise. Observation forces a choice, not a choice made by thought, but by physics. A choice that turns a spectrum of possibilities into a moment of certainty. To help the mind relax into this idea, imagine a feather floating in a room with no air currents. The feather hovers, drifting without direction, not choosing where to fall. Then a single breath of air touches it, and in that instant, the feather settles on a single path. Measurement works this way, but on a scale far smaller than feathers or even atoms. Reality waits for its smallest nudge. And until that nudge arrives, it remains open, uncommitted, woven from many potentialities. One of the most sleep-friendly ways to imagine this behavior is to think of the quantum world as a soft mist, a mist that fills the space around you, not with water droplets, but with probabilities. Every particle is a tiny swirl within that mist, not located at a single point, but spread across possibilities. Only when something interacts does the mist draw together, forming a small, bright droplet of certainty. Before that moment, the mist is the truth. After the moment, the droplet becomes the measurable result. This gentle metaphor captures the essence of superposition, the idea that particles do not occupy one state, but many, until the universe, through interaction, asks them to decide. In the classical world, such behavior feels impossible. You do not come home to find your furniture in overlapping states. You do not find your phone both on the table and inside your pocket until you check. The large-scale world is too saturated with interactions. Every surface, every particle of air, every vibration is constantly measuring, constantly collapsing, constantly stabilizing. It is as if the universe is continually watching itself, simplifying quantum mist into definite outcomes. But in the quiet isolation of a controlled experiment, the underlying truth emerges. Particles behave like waves until they are observed. This contrast between classical certainty and quantum fluidity invites a profound question. What is more fundamental, the solidity we experience or the shimmering quantum haze beneath it? The answer, as far as physics can tell, is that the haze comes first. The particles become solid only when touched, only when measured, only when observed. And that observation does not need to be mystical or intentional or conscious. It only needs to be physical. A detector clicking, a photon bouncing, a fragment of the environment interacting. Reality at the smallest scales responds to being noticed, even if the noticing comes from an inanimate object. As your body continues to relax, as your breath settles into an even, quiet rhythm, you can feel the gentleness of this truth. The smallest building blocks of the universe do not reveal themselves until the faintest touch arrives. They are not solid things moving through space. They are possibilities, waiting to be shaped, waiting to be measured, waiting to be observed. In this way, observation is not an intrusion. It is a necessary part of reality, a bridge between the potential and the actual, a connection that transforms the wave into the particle, the maybe into the moment. And as these ideas settle softly into your awareness, you may feel your mind floating gently, drifting between wonder and rest. This first section has revealed the core mystery, that the smallest scales of reality do not behave like the world you know. They behave as waves, as possibilities, as superpositions, until something observes, and only then does the universe commit to a definite outcome. To understand why reality shifts the moment we observe it, we must drift deeper into the meaning of observation itself. Because in everyday life, to observe is to look, to see, to use your eyes to gather information. But in physics, observation is not about sight. It is about interaction. It is about physical contact, the gentle exchange of energy, momentum, information. Observation is not what the mind does. It is what the universe does when two systems meet. And as you settle deeper into the calm of this moment, you can let this idea slowly unfold. At the quantum scale, to observe something means to disturb it, not intentionally, but inevitably. Because the act of gathering information requires interaction, and interaction always changes the system. Imagine holding a small soap bubble with absolute delicacy. Even the softest touch distorts it. Even the slightest impact changes its shape. Quantum systems are even more fragile. A single photon touching an electron, a single vibration from a measuring device, a single disturbance from the environment. All of these interactions collapse superposition, not out of malice, but out of necessity. To know something at the quantum scale is to affect it. Just as breathing affects the flame of a candle, even if the breath is faint and unintentional, your eyes cannot see electrons, neutrinos, or microscopic superpositions. To observe them, scientists use light, or detectors, or magnetic fields. But every tool must touch the system, and the moment it touches, the system changes. This is why observation cannot be passive. It is always an interaction, a conversation between the measuring device and the particle, a tiny exchange that forces the universe to choose a definite outcome. But observation goes deeper than the simple act of touching a particle. There is a boundary, a quiet, delicate frontier between observer and system. And at the quantum level, that boundary is not fixed. It shifts, it blurs, it dissolves. Because the observer is also made of particles, the detector is also quantum. The measurement device interacts with the system, but the system interacts right back. And at this interface, something irreversible happens. The wave function, the soft haze of possibility, spreads outward, meets the detector, and entangles with it. Entanglement is the beginning of observation. It is the moment when the two systems can no longer be described independently. They become linked, like two ripples merging in a pond, like two shadows overlapping at dusk. And once entangled, the system begins to lose its delicate coherence. Coherence is the property that allows superposition to exist. It is the quiet alignment of possibilities, the structure that supports wave-like behavior. But interactions shake that structure. They scramble it, spread it, mix it with the environment. And in that mixing, something beautiful and inevitable occurs: decoherence. the gradual loss of quantum possibility, the soft fading of superposition, not because it is destroyed in a single moment, but because the system becomes tangled with the world around it. The information about its state spreads into the environment, and once the environment knows the result, even faintly, the superposition is lost. This is observation, not a conscious event, but a physical one, a flow of information from the quantum system into the world, a tiny exchange that collapses possibility into definiteness. To make this idea more sleep-friendly, imagine a drop of ink falling into a glass of water. At first, the ink is coherent, a single droplet, but the moment it touches the water, it begins to spread. It disperses, mixes, fades. Soon, there is no boundary between ink and water. The droplet becomes part of its environment. This is decoherence, a quantum system gradually losing its distinct identity, becoming absorbed into the larger world, and once this mixing occurs, the system can no longer maintain a clean superposition. Its wave-like nature dissolves, leaving behind a definite outcome. This is why the universe cannot hide from interaction. Every surface, every molecule, every photon plays the role of observer. Even darkness is filled with invisible particles that measure and influence. Observation is woven into the fabric of existence. And yet, there is still something subtle and mysterious about the collapse of the wave function. Because collapse is not merely about disruption, it is about information. To observe something is to gain information. To gain information is to force possibilities into a definite shape. A wave function contains every possible outcome weighted by probability. But the moment information is extracted, even a tiny piece, the wave function collapses. What was once a spectrum becomes a single point. What was once everywhere becomes somewhere. What was once many becomes one, like a whisper turning into a single word, like a fog condensing into a droplet. This connection between observation and information is one of the deepest truths in quantum physics. It suggests that reality on the smallest scale is not a set of pre-existing facts. It is a field of potential outcomes, waiting for a question, waiting for an interaction, waiting for information to be drawn out. Only then does the universe answer. Only then does a definite outcome occur. Observation is the asking of the question. Measurement is the universe's reply. But why does the universe respond this way? Why does information dictate reality at the quantum scale? The answer lies in how wave functions encode possibility. A wave function is not a physical wave, it is a mathematical landscape, a map of all the futures a particle could take. When unobserved, the particle drifts across this landscape, exploring all paths, all states, all potentials. But once observed, the landscape collapses to a single route, because the universe can no longer maintain the overlapping pathways. Information forces commitment, and commitment creates reality. This is why reality at human scales feels stable. Everything around you is constantly measured, constantly interacting. Air molecules, sunlight, thermal vibrations, collisions between atoms, all of these interactions are measurements. The environment is observing everything all the time, and because the environment is so large, its measurements are overwhelming. Quantum superpositions collapse instantly, leaving behind the classical world, the world of objects, solidity, definiteness, the world where things exist whether you look or not. But at the foundational level, that stability comes from endless observation, from the universe constantly interacting with itself, from decoherence sweeping away superpositions, from information forming the backbone of what we call reality. As you rest here, breathing slowly, feeling the quiet settle around your thoughts, you can sense how intricate and delicate this chain of ideas is. Observation, interaction, information, decoherence, collapse, all working together to create the world you know, the stable, solid, reliable world, built from a foundation of shimmering possibility, measured into existence, observed into form. The boundary between the observer and the system being observed is not a clean line, not a hard edge, not a wall, but something fluid, porous, quietly shifting. In classical life, you feel separate from what you observe. You look at a tree and you believe the tree is over there and you are over here. You watch the moon and nothing you do seems to influence its presence. But in the quantum world, the observer and the observed cannot remain independent. The moment an interaction occurs, the boundary dissolves, their states intertwine, merge, entangle. And this merging is not just a poetic idea, it is a physical process. The wave function of the particle and the wave function of the measuring device combine, they link, they form a new joint system. One cannot be described without the other. This quiet merging is the first step of observation. Before any collapse, before any definite outcome, there is entanglement. A joining of the fates of two systems, a subtle choreography between what is measured and what does the measuring. And because this entanglement changes both systems, observation at the quantum scale is never passive. It is always participation, always involvement, always influence. Even if the interaction is tiny, even if it is the touch of a single photon, the disturbance is unavoidable. Quantum systems are too delicate to be probed without being altered. To measure an electron, you must send a photon toward it. But photons carry energy, and when they collide with the electron, they change its motion. They change what you're trying to measure. This unavoidable disturbance is not a flaw in our devices. It is a fundamental property of reality. At small scales, to know is to disturb, to observe is to change, to measure is to influence. And this influence is what collapses the wave of possibilities into a single outcome. To visualize this, imagine a sleeping pool of water. Its surface is perfectly still, smooth, undisturbed. The quantum state is like that stillness, a coherent spread of possibilities. But the moment you touch the surface, even gently, ripples appear, patterns shift. The calm is broken, not destroyed, but altered. The water remembers that you touched it, and the quantum world remembers too. Every disturbance becomes a measurement. Every measurement becomes a shift. Every shift brings the wave function closer to collapse. Decoherence deepens this transition. Decoherence is the process by which the delicate overlap of possibilities is scattered into the environment. Imagine a violin string vibrating softly. Its tone is pure, clear, harmonious. But if something brushes the string, a feather, a fingertip, a grain of dust, the vibration changes, loses purity, loses coherence, becomes mixed with the disturbance. At the quantum level, the string is the wave function, the brush is the environment. Every interaction adds noise. Every collision with air molecules, every vibration, every thermal fluctuation adds information, and as information leaks out, the coherent superposition fades. The quantum state is no longer delicate, no longer spread. It has become entangled with everything around it. And in that entanglement, certainty emerges. Not because something decided, but because the structure of the wave function cannot maintain superposition once the world has begun to learn about it. Decoherence is the world listening, quietly, constantly. And when the world listens, the quantum state changes, the wave collapses, the particle chooses, reality settles. This process makes it impossible for the universe to hide from interaction. Even in deep space, far from planets, far from stars, tiny interactions occur. Cosmic microwave photons, stray particles, fluctuating fields. The universe is never perfectly silent, never perfectly isolated, and because of that, quantum systems seldom remain untouched. Even the emptiness of space performs a kind of measurement, a faint one, a slow one, but a measurement nonetheless. This is why perfect superpositions are so rare in nature. They require isolation, shielding, protection from the world, and yet the universe constantly watches. Through every interaction, every exchange, every ripple of information, reality at large scales is stable precisely because the environment measures everything. Atoms in your body collide with one another, billions of times per second. Each collision is a tiny measurement. Each vibration is a disturbance. Each interaction is a collapse. These countless measurements happen continuously, and together they create the illusion of a world that does not depend on observation. But beneath that stability is an ocean of quantum events, each one forcing a choice, each one selecting a definite outcome, each one stabilizing the classical world. The environment is the ultimate observer, not conscious, not intentional, but omnipresent. Omnipresent in the sense that it is always there, always interacting, always influencing, always collapsing the delicate wave functions that define the smallest scales. The air around you, the warmth of your skin, the photons in this room, all are acting as continuous monitors, gathering information, spreading it, and stabilizing reality. This is why a chair remains a chair, why your phone stays where you left it, why the moon follows its predictable path. It is not because the laws of nature are rigid, it is because the universe is constantly self-observing, a network of interactions, endless, unceasing, woven through every moment. This network is what gives birth to classical reality, a world that feels solid, stable, independent, even though beneath it lies a realm of shimmering possibility. Wave functions, probability, collapse. These words are not abstract. They describe how the universe breathes, how it moves from the soft haze of potential into the sharp clarity of experience. A wave function is a mathematical field of potential outcomes. Probability is the weighting of those outcomes, and collapse is the moment when one possibility is chosen, not chosen by thought, not chosen by intent, but chosen by physical interaction, by information flow, by measurement. You can imagine collapse as the settling of dust in a sunbeam. The dust floats, drifts, suspends in light, each particle in many possible positions, but when a current of air arrives, the dust settles, not at random, but according to the motion of the air. Collapse works this way. Possibilities float, interactions arrive, the system settles, not into chaos, but into a definite shape, a single outcome, one path among the many. As these ideas move through you, notice how gentle the quantum world becomes. It is not violent, not abrupt, not mystical. It is subtle, responsive, shaped by touch, shaped by interactions too small to feel, shaped by information too faint to notice, yet powerful enough to define everything you experience. You may begin to sense why reality at human scales feels so distinct from the strange fluidity beneath it. The classical world is a world after decoherence, a world after collapse, a world after the environment has smoothed and stabilized countless uncertainties. But deep beneath this calm surface, reality remains quantum. Even if you never see it, even if you never feel it, even if you never notice the shimmering possibilities that lie beneath the ordinary, they are always there, waiting, waiting to be touched, waiting to be observed, waiting to become real. The question drifts into your awareness like a soft ripple across a still lake. Does reality exist before we look at it, or does it wait in some quiet, suspended form to be shaped by the act of observation? As you breathe slowly and feel your body sinking deeper into rest, you can let this question unfold without urgency. There is no need to chase answers, only to drift with them, gently, as if floating on a dark, calm sea. In the classical world, existence feels simple. Objects exist whether you see them or not. A stone on a beach, a mountain beneath clouds, a planet on the far side of the sun. You do not need to look for these things to be real. But quantum reality does not obey this intuition. At the smallest scales, the question of existence is different from the question of definiteness. A quantum particle may exist, but not in any definite form, not in one state, but in many. This is the difference between existence and definiteness. Something can exist as a field of possibilities, a wave function, a shimmering distribution of potential outcomes. Without possessing a single definite value, the unobserved world is not empty, but it is not definite. It is a landscape of might be, could be, may become, a realm where outcomes are suspended until an interaction pulls them into focus. To help this idea settle softly, imagine a book filled not with sentences, but with countless drafts. Every page holds dozens of potential stories. Nothing has been chosen, nothing finalized. The book exists, but the story is not definite. Observation is like opening the book to a single page, a single sentence, a single version. The other possibilities do not vanish in fury. They simply recede quietly as one outcome becomes the one that is experienced. The quantum world is this book of drafts, and reality, as you experience it, is the page revealed when observation occurs. Schrödinger's cat is the most famous metaphor for this idea. A cat placed in a box, its fate tied to a quantum event. Before observation, the cat is neither simply alive nor simply dead, but in a superposition of both, not because the universe is cruel, not because the cat is somehow divided, but because the quantum trigger has not yet interacted with any observer. The system remains suspended, a blend of possibilities. Only when the box is opened, only when interaction occurs, does the system collapse into a single outcome, alive or not. One fate chosen from the spectrum. This thought experiment is not meant to be literal, but conceptual. A way to reveal the strange truth that unobserved systems do not possess definite states, not until measurement gives them one. Interpretations of quantum mechanics attempt to explain why this happens, why reality behaves in this soft, hesitant way. why possibilities must collapse into single outcomes. And each interpretation offers a different picture, a different way the universe might be structured, none proven, none dismissed, each one a window into a deep mystery. The Copenhagen interpretation suggests that the wave function is not a physical thing, but a tool for describing knowledge. Before observation, the system does not have a definite state, and after observation, it does. According to Copenhagen, reality becomes definite only when measured. Existence is tied to interaction. To ask what was the particle doing before observation is to ask a question that nature does not answer. The particle was in a superposition in all states at once, and measurement is the act that selects one. This view is pragmatic, minimal, mysterious, and it reminds you that the quantum world does not owe us classical intuition. The many worlds interpretation takes a different path. It proposes that the wave function never collapses. All outcomes happen. Every possibility becomes real in a branching universe. If a particle can go left or right, then one universe contains the left path, and another contains the right. If Schrödinger's cat can be alive or dead, one universe holds life, another holds stillness. Collapse is an illusion. Superposition splits the cosmos into countless worlds, infinite versions of every event, infinite branches, infinite universes, none contradicting, all existing. This interpretation does not answer what is real before we look, but transforms the question. Everything is real, but in parallel, you only observe one branch, one thread, one version, as if consciousness follows a single line through a forest of infinite possibilities. Objective collapse theories take yet another route. They propose that wave functions collapse on their own, not because of observation, not because of measurement, but because the universe has a built-in mechanism that suppresses superposition after a certain scale. A particle may remain in superposition, but a cat cannot, a rock cannot, a galaxy cannot. As systems grow larger, superpositions collapse spontaneously. The universe enforces definiteness, even without observers. This interpretation suggests a world where objective physical reality exists independently, but is shaped by laws that eliminate ambiguity, slowly, inevitably. Like frost spreading across a window, cubism offers another perspective. It argues that the wave function is not a statement about the system, but a statement about the observer, a way of quantifying one's expectations. Under cubism, reality exists, but the wave function is personal, a tool each observer uses to make sense of the world. Observation is not discovering a pre-existing property. It is updating one's knowledge, one's beliefs, one's expectations. Quantum mechanics becomes a guidebook, not a map, a method for navigating uncertainty, not describing a hidden world, and reality remains mysterious, private, somewhere beyond what equations can say. Each interpretation tries to answer the same question. What is real before we look? Is the unobserved world a haze of possibility, a branching multiverse, a process waiting for collapse, a reflection of our beliefs? No interpretation has become definitive. All remain alive. All remain debated. All reveal that even with a century of experiments, we still do not know what reality looks like when unobserved. And yet there is something deeply calming in this uncertainty, something soft, dreamlike, gentle, because the idea that reality hovers between states, like a breath held in the dark, mirrors the way your consciousness drifts as you fall asleep. In dreams, possibility expands, time stretches, boundaries soften, and your awareness moves through states that are not definite, not rigid, not fixed. Dreaming is its own kind of superposition, a blend of memory, imagination, sensation, emotion, a field of overlapping scenes, a reality not yet collapsed, a universe not yet chosen. And when you wake, the dream collapses into memory, just as observation collapses the wave function into a single outcome. Your mind, in sleep and in waking, mirrors the structure of the quantum world, possibility narrowing into experience, uncertainty turning into moment. The dream world is not the quantum world, but the rhythm is similar, the way they ebb, flow, expand, and condense. Both reflect a universe that is not always definite, a universe that waits to be touched, a universe that rests in potential until the moment of interaction. As you sink deeper into rest, the question becomes softer, yet somehow more intimate. What role does the observer play in shaping reality? Not the dramatic version, not the mystical idea that consciousness creates the universe, but the quiet, scientific truth that observation, in its simplest form, changes the physical world. And in doing so, it invites us to reconsider what it means to be an observer, not as a creator, but as a participant, a subtle presence woven into the fabric of measurement. There is a difference between the observer effect and the claim that consciousness actively creates reality. The observer effect is simple, precise, and supported by decades of experiments. It states that measuring a system changes it because measurement requires interaction, and interaction always influences a quantum state. This influence is not a product of intention, not a product of awareness, not a product of consciousness. It is a product of physics, the gentle push of a photon, the vibration of an atom, the smallest whisper of energy exchanged. These are the forces that shape outcomes, not the mind, but the world, touching itself again and again. Yet human consciousness does add something special, not because it collapses wave functions, but because it gives meaning to the outcomes. It is not consciousness that makes the universe real. It is consciousness that makes the universe experienced. Physics does not require a human observer to form reality. Measurements occur everywhere, without intention, without awareness. But awareness is what allows us to reflect on those measurements, to ask questions, to interpret patterns, to wonder, and in that reflection we sense something profound. The universe feels participatory, not because it depends on us, but because we are part of it. Entangled not at the level of wave functions, but at the level of meaning, interpretation, curiosity, wonder. To understand this more deeply, imagine that every quantum interaction is a small exchange of information. Each interaction updates the universe. Each measurement is a tiny message, a bit of structure, a bit of difference, a bit of pattern. Information is the thread that connects events, the thread that shapes outcomes, the thread that holds the universe together. This idea that information is more fundamental than matter itself was championed by the physicist John Wheeler. He expressed it simply, it from bit. Meaning, what exists arises from information. A physical it emerges from a bit, a unit of content, a piece of structure, gleaned from interaction. The universe not as a machine, but as a tapestry woven from signals, from measurements, from differences, from informational choices. And in this tapestry, observers play a role. Not as creators of reality, but as nodes in the network of measurement, points where information is gathered, interpreted, reflected. The universe creates itself through interaction, and we are simply one part of that process, one branch of the great network, one thread in the web of measurement. If you imagine the universe as a vast forest, stretching beyond sight, you can also imagine that every leaf, every gust of wind, every movement of a branch creates a tiny signal. A shift in air, a vibration, a ripple of information, all of it is part of the forest's life. The forest does not require a human hiker to know it exists. It is constantly observing its own motion, every leaf measuring sunlight, every root measuring moisture, every insect measuring chemical signals, information flowing everywhere. We enter the forest and interpret what is already happening. We experience the forest. We do not create it, but our presence changes our personal experience of its patterns. Awareness adds meaning, interpretation, reflection, and with reflection comes a strange sense of participation. Not control, but connection. This is how the universe feels at the quantum level. All systems are measuring each other. Particles, fields, radiation, atoms, all exchanging information, all collapsing one another's possibilities, all contributing to the stabilization of classical reality. In this ocean of constant interaction, human beings do not stand apart. We are part of the network. Our measuring devices, our senses, our thoughts, our interpretations, these are just more nodes in the web. More points where information converges, where uncertainty dissolves, where outcomes are read, experienced, given meaning. Awareness is not required to collapse wave functions, but awareness is what allows us to understand that they collapse, to question why, to explore the strange mathematics beneath perception, to feel the quiet wonder of knowing that reality is not entirely fixed, not entirely rigid, not locked into one shape. Possibility is always humming underneath. A soft vibration, a hidden potential, waiting to be nudged, waiting to be measured, waiting to become real. Human consciousness becomes a kind of mirror held up to the universe, not shaping it but revealing it, not altering the laws but experiencing their consequences. And in this mirroring, we sense a quiet harmony, a feeling that we belong here, because we are made of the same particles, obey the same physics, follow the same informational rules. The universe is not divided into observer and observed. It is a single field, a single web, a single unfolding. We observe the universe, but we are also the universe observing itself, through our senses, our instruments, our reflections, through our wonder, through our curiosity, through the quiet act of listening to the mysteries that surround us. Even now, as you drift deeper into a slower breath and a softer awareness, you are participating in the process. Not by collapsing wave functions, but by allowing your mind to reflect, to feel, to connect, with the strange, delicate truth that reality is shaped by interaction, and awareness is one form of interaction, one window into the workings of nature, one gentle presence in the quiet flow of measurement. As you rest here, breathing softly, letting the quiet settle around your thoughts, you can begin to sense something subtle, something vast, that the universe does not simply wait for humans to observe it. It observes itself, continuously, effortlessly, through the endless interactions of particles and fields. A cosmic dance of measurement, a web of mutual observation, a universe woven from the act of everything touching everything else. This truth reveals itself when you consider how many interactions take place in even the smallest moment. Photons streaming from stars, bouncing off dust, off planets, off the surfaces of distant moons. Atoms vibrating, colliding, exchanging energy, magnetic fields shifting across space, gravity bending trajectories. Every interaction is a kind of observation. Not deliberate, not conscious, but real, physical. The universe measures itself through the exchange of information. One particle nudges another, which nudges another, which nudges another. And in that cascade of contact, probabilities collapse, properties become definite, superpositions fade. Reality takes shape, not because someone is watching, but because everything is watching everything. All the time. Imagine a quiet forest with no animals, no hikers, no eyes, yet the forest is full of observation, roots measuring moisture, leaves measuring sunlight, air measuring temperature, rain measuring gravity, everything interacting, everything responding, not consciously, but physically. The forest learns about itself through the flow of information. The universe works the same way. Even in absolute silence, even in the emptiest regions between galaxies, there are particles exchanging information, colliding, interacting. A cosmic forest measuring itself, moment by moment. Photons are among the most active messengers in this self-observing universe. A single photon can travel for billions of years across the darkness of space. Along the way, it may pass by planets, skirt the edges of black holes, scatter off dust, and each interaction is a small observation. The photon gathers information, and in that gathering, it shapes what becomes real. Because when a photon strikes a particle, it forces a choice, a position gained, a momentum altered, a probability wave collapsing into a single outcome, a tiny moment of cosmic measurement. Atoms are also observers, even though they possess no awareness. An atom colliding with another is a measurement. Their wave functions become entangled, their states become linked, a superposition dissolves, a definite outcome emerges, and the universe takes another step along its unfolding path. These interactions happen on a scale so small that you cannot feel them, yet they are constant. Billions upon billions within the space of a breath, a network of microscopic observations, a vast tapestry woven from the gentle collapse of possibility. And consider the cosmic web, the enormous structure stretching across billions of light years, composed of filaments of galaxies, threads of dark matter, clusters glowing with starlight. This web is not static. It is alive with interaction, galaxies pulling one another through gravity, gas clouds colliding, radiation streaming, magnetic fields twisting. Every one of these processes is a chain of measurements. Over cosmic timescales, the universe constantly updates itself, constantly collapses superpositions, constantly moves from possibility into reality. The universe does not need human eyes to be observed. It observes itself through the ceaseless exchange of information, through the dance of its own laws. Stars are also observers, not in any conscious sense, but because they are enormous engines of interaction. They fuse hydrogen, release photons, spew neutrinos, shape the movement of matter. Everything that touches a star is changed. Everything that approaches it is measured. A star's light collapses the states of particles around it. A star's gravity nudges the trajectories of passing objects. A star's magnetic fields record the patterns of charged particles. Every star is a node in the universe's self-observing network, a point where possibilities narrow into outcomes, a moment where the universe touches itself. And between stars, in the vast emptiness of interstellar space, dust grains drift. Even a grain of dust can observe. If a photon strikes it, if a gas molecule collides with it, if a cosmic ray passes through it, any interaction becomes a measurement. Any measurement creates a definite outcome. The universe does not need human observers. It is filled with endless observers, endless interactions, endless collapses, endless creation of reality. This truth brings something peaceful into your awareness, a recognition that reality is never waiting for you. It is always forming, always unfolding, always becoming definite, moment by moment, interaction by interaction. Even in the absence of consciousness, even in the quiet darkness of empty space, the universe is constantly watching itself, constantly shaping itself, constantly collapsing its own possibilities into the classical world we experience. And yet, when a conscious being steps into this network, something shifts, not in the physics, but in the meaning. Because consciousness reflects, interprets, contemplates, while a photon observes through interaction, consciousness observes through awareness, through experience, through curiosity, through understanding. And in this way, consciousness becomes the universe reflecting upon itself, not creating reality, but making sense of it, not collapsing wavefunctions, but collapsing ideas, uncertainties, questions, into insight, into knowledge, into wonder. This gentle reflection gives rise to one of the most poetic ideas in all of science, that we are part of the universe looking inward, that we are the cosmos becoming aware of its own structure, its own behavior, its own laws, as if consciousness is the universe discovering itself, unfolding its own secrets, listening to its own patterns, watching the echoes of its own interactions. And as you drift deeper into calm, you may sense how serene this idea feels. That you are not separate from the universe, not an outsider looking in. You are a participant, a node of awareness, within a vast field of interactions. You are made of the same particles that collapse one another's states, driven by the same laws that govern galaxies, carried by the same forces that shape stars, fields, and atoms. You are not merely in the universe. You are the universe, part of its flow, part of its structure, part of its self-observation. As you breathe, the universe breathes. As you reflect, the universe reflects. As you rest, the universe continues its endless unfolding, watching itself, measuring itself, becoming real moment by moment. As you lie here, breathing softly, your body gently sinking into whatever surface supports you, the vastness of everything you've heard begins to settle, not as a blur of scientific detail, but as a feeling, a sense, a quiet recognition that the smallest layers of reality and the quiet rhythms of your own mind share a strange and gentle kinship. Because when you rest, when your thoughts begin to loosen, and your awareness grows soft, you drift into a state where certainty fades, where the boundary between what is seen and what is felt begins to dissolve, where the world does not press upon you with sharp edges, but floats instead in a soft haze of impressions, a state not so different from the superposition that lives at the heart of quantum behavior. The quantum world shows us that possibility is not an abstract concept. It is a real structure, embedded in the foundation of the universe. And as you relax, you can feel how possibility flows through your own life, your own thoughts, your own experience. A moment before you decide is a moment of superposition. A breath before you act is a soft cloud of potential outcomes. Your awareness collapses these possibilities into choices. Your attention shapes the path you walk, not through magic, but through biology, psychology, and quiet focus. Attention is a kind of observation, a gentle form of measurement, a way of selecting from the many possible experiences offered to you. And in this way, your relationship to the world mirrors the universe's own relationship to possibility. When you bring attention to your breath becomes real in your experience. It sharpens, clarifies, takes form. When your attention drifts, your experience slides back into softness, into a kind of mind-level superposition, where impressions overlap and thoughts move without clear direction. This soft, drifting state is what allows you to fall asleep. It is your mind letting go of definite outcomes, releasing the need for precise observation, allowing uncertainties to exist, allowing thoughts to blur and dissolve, allowing possibility to take the place of intention, and eventually allowing consciousness to rest. Just as quantum systems rest in superposition when they are untouched, when they are uninfluenced, when they are not being measured, your mind enters a similar state, a gentle haze, a quiet mist, a soft cloud of thoughts. This is why the quantum world makes such a comforting companion for sleep, because its deepest truths are not abrupt or violent or chaotic. They are gentle, fluid, quiet. They reveal a universe where definiteness is not always required, where possibility is a natural state, where uncertainty is not a threat but a kind of freedom, a space for something new to emerge. And as you drift, you can sense how this mirrors your own journey inward, into calm, into rest, into the soft blurring of thought. The idea that attention shapes experience also has a soothing quality, because it means you are not trapped in the momentum of your day. Your attention can shift, and whatever you attend to becomes the center of your experience. Right now, your attention is resting on calmness, on softness, on the gentle rhythm of your breath. And because you attend to it, it becomes real. In your awareness, it grows, expands, gently fills the space of your mind, just as a measured quantum state becomes definite. Your calm becomes definite when you observe it. Your relaxation becomes real when you feel it. Your rest takes form when you let your awareness collapse into it. This is the quiet beauty of observation, not the kind that collapses particles, but the kind that collapses experiences, shifts states of mind, brings clarity to what you choose to rest upon. If your attention wanders to worry, worry becomes real. If your attention wanders to peace, peace becomes real. Attention is not magic. It is simply the way your brain shapes its own experience, focusing energy, selecting signals, quietly collapsing its own internal wavefunctions, choosing what will fill your moment, your breath, your heartbeat, your stillness. These become real as you observe them. The quantum world also teaches that even when things feel uncertain, there is structure, there is order, there is a hidden logic beneath the surface. Uncertainty is not emptiness. It is possibility, and possibility is fertile, alive, vibrating with potential. When you lie awake at night, uncertainty can feel heavy, but uncertainty in quantum physics is a sign of richness, of abundance, of options. And when you adopt this perspective, your own uncertainties feel softer, less threatening, more like open space, a gentle field of maybes, inviting, not intimidating. Even your thoughts, even your worries, begin to dissolve, because uncertainty is not a mistake. It is a natural state. Just as particles rest in superposition, the mind can rest in openness, without forcing outcomes, without needing answers, without collapsing the moment before it is ready. Breathing becomes a kind of measurement. Feel your inhale gentle, unforced. Feel your exhale slow, soft. With each breath, your mind collapses into the present, into the immediate, into the calm. Breath is the simplest form of observation. It anchors you, stabilizes you, pulls your awareness away from the swirl of possibilities and into the quiet certainty of this moment, this breath, this stillness. As you relax further, you can sense how the quantum world and your inner world echo one another. At the smallest scales, possibility becomes reality through interaction, and in your own experience, possibility becomes reality through attention, through awareness, through gentle focus, not through force, not through effort, but through choosing what you allow to fill the space of your mind. Right now, you are choosing calmness, choosing softness, choosing rest, and your awareness is collapsing your moment into serenity. This is why all of this matters for sleep, because sleep is the act of letting go of measurement, letting go of sharp edges, letting go of the tight grip on belief and certainty. Sleep begins when you allow your thoughts to drift into possibility, when you stop forcing them into definite shapes, when you let your awareness become soft, open, unfocused, like a wave function spreading, gentle, quiet, unmeasured, until consciousness itself collapses into dreaming, then into deeper rest, and finally into stillness. Your mind is a universe too, a universe flowing from moment to moment, from possibility to experience, from uncertainty to rest. And as you drift deeper, you can feel that you are not separate from the quantum world. You are part of it, shaped by it, built from it. You are a gentle expression of the same laws, the same particles, the same unfolding, and your rest, your calm, your peace, is simply another way the universe is observing itself, quietly, softly, through you. As you drift deeper into the quiet space between waking and sleep, the universe begins to feel softer, more distant, yet somehow more intimate. Because even now, as your thoughts loosen and your awareness becomes light, the cosmos continues, quietly, patiently, unfolding its laws moment by moment. Whether you watch it or not, whether you measure it or not, whether consciousness is present or dissolving into dreams, the universe moves forward, constant, silent, vast, a steady pulse of interactions, collapsing probabilities, shaping outcomes, weaving reality, without pause, without hesitation, without ever needing anything from you. And there is a deep comfort in knowing this, a comfort in the thought that reality does not depend on your vigilance or your effort or your attention. The world holds itself together through forces far older and far more ancient than memory. Gravity, electromagnetism, the strong force, the weak force. Fields stretching across space, particles exchanging information, energies shifting, vibrations echoing, all continuing, with or without your awareness, all continuing as you rest. The idea that reality exists only when observed is subtle, because at the human scale, the universe feels definite, solid, reliable. But at the quantum level, observation is simply interaction, a contact, a nudge, a ripple of information. Every star, every molecule, every grain of dust is observing something, measuring something, exchanging information, shaping reality. Long before you opened your eyes, long before life itself began, the universe was already watching itself, already collapsing possibilities, already forming galaxies and stars and planets. Long before you, long after you, in ways so gentle and so vast that the mind can barely grasp them. And yet, as you lie here, you are part of that same unfolding, part of that same fabric, part of that same quiet dance, your breath, your heartbeat, your thoughts dissolving into softness, all of it made from the same particles that drift through the cosmos, all of it obeying the same laws, the same mathematics, the same delicate flow from possibility to existence. You are the universe in a moment of rest, the cosmos taking a breath, the atoms of ancient stars experiencing calm, the particles that once wandered between galaxies now settled into stillness, waiting, breathing, dreaming, through you, and when sleep arrives, you enter a different kind of observation, one that does not collapse particles, but collapses thoughts. Dreams are not definite, they shift, blur, recombine, just like quantum states before measurement. A dream can be many things at once, a place, a memory, a possibility. Your mind drifts between them, unconcerned with logic, unconcerned with precision. In dreams, you witness the same fluidity that defines the quantum world. Not literally, but conceptually, your awareness moves through possibilities without anchoring them, until you wake and the dream collapses into a single memory, a fragment of something larger, a trace of many overlapping states. Just as the universe collapses only a single outcome when observed, your mind collapses only a single version of a dream. Even though so many forms were possible, this symmetry between dreaming and quantum ambiguity is gentle, poetic, and calming, because it reminds you that uncertainty is not the enemy, it is simply a state of openness, a wide horizon, a quiet field of possibility, inviting your awareness to rest, to drift, to dissolve. And even while you sleep, the universe continues, quietly, silently unfolding. Stars explode, galaxies collide, particles scatter, planets orbit. Even in the smallest spaces, interactions ripple, measurements occur, reality takes shape, but none of it demands your attention. None of it requires your knowing. The universe is not waiting for you. It does not depend on you. But it includes you. You are woven into it, held by it, carried by it, and in sleep, you return to a state of soft openness, a state where awareness is thin, light, delicate, and the boundaries between yourself and the cosmos begin to blur. Not in a mystical way, but in the simple truth that you are made of the universe, and the universe continues through you, even as your consciousness rests, even as your thoughts fade, even as your awareness slips beneath the surface. There is something peaceful in this thought, that the universe does not need to be watched to continue, that reality, with all its interactions, with all its measurements, with all its quiet collapses, moves gently onward, steady, unbroken, eternal. And you can let go, you can drift, you can allow yourself to rest, because the world holds itself, because reality carries its own weight, because the cosmos remains stable, even when your awareness slips away. You can surrender to sleep, knowing the universe is unfolding gently, softly, exactly as it should, whether you are awake or dreaming or resting in the deepest quiet. And in that quiet, you become part of the cosmic story, part of the endless chain of interactions, part of the universe that knows itself through experience, not by creating reality, but by sensing it, reflecting it, feeling it, for a brief moment in the long history of stars and galaxies. You are the universe knowing calm, the universe knowing stillness, the universe knowing rest. And as you drift into deeper sleep, this feeling grows softer, more spacious, more serene, like a whisper carried across the night, a gentle reminder that you are part of something vast, ancient, mysterious, and that the mystery continues even as you dream, even as consciousness lets go, even as you drift into the quiet darkness. The universe continues, steady, silent, beautiful. And you float within it, held, carried, at peace. The story ends here, but the cosmos does not. It goes on in its slow, perfect unfolding. As you sink into sleep, a soft whisper fading into infinity, a gentle calm carrying you into rest. The universe continues when you dream and when you don't, and you are part of that eternal quiet. Good night.